Becca, my first question has to be, what are we looking at currently in terms of science and technological developments?
So our definition of science and technology and the areas that our responsibility covers include a vast array of technologies, because technology can be anything from the tractor that tends the fields to the rocket that's sending a satellite up into space. So we literally cover everything from ground to the stars. And so we're looking at a number of different things. We're looking at advancements in materials science and in 2D materials like graphene. We're looking at how drones are being used in agriculture to improve and the efficiency of agricultural techniques. We're looking at gene editing techniques and how they can improve the healthcare field, how they can improve biotechnology. We're looking at batteries and alternative technologies. We're looking at a number of different disruptive technologies that could potentially change how the world works in the future.
And I think that's really good to mention, because one of the questions we sometimes get is, clearly we have a big focus on science and technology. Why? And it fits very well into our overall geopolitical framework for the reasons you just mentioned. Because actually, we talk about the limitations imposed by geography, but through science and technology, it's a way of actually breaking those bonds and moving beyond it. So what are you seeing this year that has really, made an impact on your perception of emerging and disruptive technologies?
So one of the things we've been focusing on a lot in the last several months is how automation and artificial intelligence will impact manufacturing and transport moving forward. So looking at how automation will continue to increase in manufacturing and how that has the potential to shift globalization away from the giant global market we know now to something that might be a little bit more regionalized, as we see developed economies bring manufacturing back to their shores as robots take more of the responsibility there.
And it seems to me that one of the most consumer-facing aspects of automation that I can think of anyway is automation in cars or transport.
Right. So automated vehicles, we've had a lot. Tesla has been in the news a lot recently with their accidents. But how we would look at that is the potential for automated vehicles in the future. And that is to improve the efficiency of driving, not only for emissions, but for logistical issues like congestion. To change how we think about transport. It's no longer, your commute is no longer lost time in your day, things like that. But when we look at that, we look at the constraints. And one of the main constraints of that technology is not the technology itself. It's actually progressing fairly consistently. The constraint there is public acceptance. And that's really where the merge of the political and the regulations there overlaps with the technological development. And that helps to have, a science mind working with a political mind.
And that's a really good point, because often we have the technology to do something, but there isn't necessarily an appropriate regulatory environment to allow that technology to flourish. And recently we've seen that Amazon will be testing some of its delivery drones in the UK. Now, clearly your package isn't going to be dropped off by drone anytime soon, but they're already looking at a framework to enable this, even though it'll take some time. Can you speak to that?
Yeah, absolutely. So it's the British, the CAA, the British equivalent of the FAA, has approved and will be working with Amazon to test the drones. And specifically, the important part of that approval is that they have approved the use of drones not within line of sight of the pilot, which is something the FAA has yet to do. And that's extremely important for the use of drones in delivery, because you can't always see the drone and you won't always see the drone along the path. And countries that have more flexible regulations will perhaps have an advantage in the future as these technologies become more and more prevalent.
So there's a couple of intersecting technologies here, especially when it comes to looking at drones and remotely operated vehicles. Part of it is the human component and how much we want to cede control to a drone, allowing it to operate autonomously. But there's another aspect as well, looking at actually what keeps these systems powered, which leads into the battery aspect. So I guess the first question is, are we ready yet to cede control to artificial intelligence?
So, no. The computerization and the machine learning aren't to that point yet by any means. And when you talk about mobile robotics, the battery technology is still needs to develop. Battery technology is important across a wide array of sectors, from renewable energy to battery-powered vehicles to the robotics you're talking about to military applications. And it's all about getting more capacity and more power for less weight. Is basically what you're trying to do, and you're looking at several different chemical combinations, to get that kind of output, lithium-ion batteries are currently the sort of the a high water mark for battery technology right now. And that's what Tesla is using in their Gigafactory, and they're trying to bring the cost down not through new battery technologies, but through economies of scale. And that factory just had their grand opening, basically. They're not operational yet. They should be producing, if they stay on schedule, by the end of the year. So that's a concept that we're watching really closely. But we're also looking at new types of batteries, because from a chemical sense, the lithium-ion battery can only take you so far. There's still the problem of resource isolation, so that lithium only exists in certain parts of the world. So there's still that sort of geopolitical issue that comes into light. So looking at battery technologies that have less of a resource limitation, so sodium-ion batteries or organic batteries, things that aren't as limited to to a location for the raw material, and using nanotechnology to help use these new not new materials, but different materials that we haven't been able to use before in these batteries. So looking at how battery technology develops, so renewables become more cost effective to integrate to the grid, so we can see drones operated for much longer distances, so cars can operate for much longer distances, so that kind of thing.
So you mentioned the possibility of batteries using organic materials. I mean, it's obviously more abundant than lithium, more readily available. So is that a technology in battery development that you could see catching on in the near term?
Not in the near term. Battery development has traditionally been very incremental and slower than other technologies develop, and I don't necessarily see that changing all that soon. It's easy to get the electrochemical, the battery reaction, to work in a laboratory environment. Scaling up is often an issue with batteries. Bringing it to a functional technology, it can be an issue. Organic materials, organic batteries are a wide array. You can get, basically there's the kind of organic batteries where the carbon source on one of the anodes comes from organic material, and that's one way. Right now graphite is actually a pretty common source of carbon, but other sources of carbon are possible. There's also using organic compounds, so using organic chemistry and how different molecules that occur either naturally or that are synthesized can then operate and transfer electrons like the metals do now.
So I won't be plugging my iPhone into a lemon anytime soon and expecting it to charge.
No, potatoes might be your better bet, but going back to elementary school science, but no. Lithium-ion batteries will be here they will be the standard for the near term. It's just that they're not the solution for forever. And eventually we will see an alternative solution. We might see numerous alternative solutions, but I think the common thread will be that the resources used in them are common. So there'll be sodium, there'll be magnesium, there'll be organics. There'll be something that everyone has access to, or more people have access to than just the limited raw materials that we use now.
And again, it's fascinating because we do see this confluence of events. We see how, the actual production, the mining of raw materials feeds into this, but also the technology and the manufacturing capability, the research and development, and actually the funding to drive this. And I know that for a long time, the military was a big advancer of battery technology because, there's a lot of systems on the soldier, on the vehicle, in the air that require battery technology. So, clearly DARPA, other government-funded research agencies drove this development. But now that pretty much everybody carries a mobile device all the time, we've seen, huge developments driven from the commercial sector, haven't we?
Yeah, absolutely. I think the military still is a large driver in not only energy storage, but also like material science. But the commercial sector absolutely has become a large driver in energy storage technology, especially as we start to think about the Internet of Things and how everything has become connected. That is going to be more and more the norm in our lives. So everything is going to be more and more electronic. So yes, obviously the consumer side of things, it'll be a major driver moving forward, but that doesn't eliminate the military purpose. As you well know, military purposes for these technologies will also continue to drive their advancement.
Well, Becca, thank you so much for being here with us today.
Thank you so much for talking with me.